What are the advantages of using the dynamic chromatographic method, particularly in terms of analytical speed, and how does this contribute to faster results in surface area testing? How does the method achieve a lower analytical limit, and why is this an important feature for accurate measurements of small adsorption amounts? How does the high accuracy of the dynamic chromatographic method improve the reliability of the results, and what factors contribute to this precision? What role does resolution play in the dynamic chromatographic method, and how does it help distinguish between small variations in adsorption levels? Can Davis Zerns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How does the method maintain repeatability in its results, and why is repeatability a crucial factor for ensuring consistent findings across multiple tests? Why is the dynamic chromatographic method particularly well-suited for testing samples with small to medium adsorption amounts, and how does this align with its design and capabilities? How does the method perform when dealing with samples that have a small specific surface area, and what are the challenges or advantages in analyzing such samples using dynamic chromatography? What types of materials or applications would benefit most from the dynamic chromatographic method, and how can it be applied to research in areas like materials science or surface chemistry? How does the static capacity method for measuring specific surface area work, and what is the first step in preparing the powder sample for analysis? Why is it important to place the powder sample into a closed test tube of a specific volume, and what role does the test tube play in controlling the environment during the measurement process? How's the adsorbent gas N2 introduced into the sample, and what is the significance of injecting the gas under a certain pressure? What is the relationship between the pressure of the adsorbent gas and the adsorption process, and why is controlling this pressure essential for obtaining accurate measurements? How is the adsorption amount of the sample determined in the static capacity method, and how are the changes in pressure or mass used to calculate the amount of gas absorbed by the sample? What is the significance of measuring the pressure or mass changes before and after adsorption, and how does this information reveal the specific surface area of the material? What are the advantages of using the static capacity method in terms of resolution and accuracy, and why is this method considered particularly suitable for medium to large specific surface areas? How does the static capacity method perform with samples that have developed pores, and why is it well-suited for testing samples with more complex pore structures? What makes the static capacity method effective for analyzing samples with large comparative surface areas?